and please give your presentation.
Hi. Hi, can you hear me?
Yes, we can hear.
Okay. I share my screen. Do you see well?
Yes. Your screen is working well.
Yeah, thank you. Now I will start my presentation. It's an honor to be present at a precious event with you. I'm sorry my English is not fluent. And I want to tell you why I begin to donate my music talent and how I feel while I share my talent. I wanted to give confidence and challenges through music and foreign languages to children who want to make their circumstances or situation better. What talents and abilities do you have? Have you ever been envious of other people's talents? What was it? I talk about my childhood shortly. My parents were not wealthy, but my mother was very interested in education. So I was able to learn the piano from an early age. In the world, to acquire a skill or ability, we have to pay a lot of time, effort, and money, especially for art. Many children have to give up their dream. And now let's see my performance on video. The pianist who survived the Holocaust played on the film Chopin Waltz. Thank you. Have you enjoyed it? I'm a pianist. I'm a classical pianist. Let me introduce myself. I'm Jeong Myung, a Korean pianist and balancing artist, piano teacher, a leader of Wow Company Artist Society. I graduated Seoul Music and Art High School and Ewha Women's University, and I studied in Germany, Karlsruhe and Köln. In Heidelberg, I studied German language. I'll show you. I donated my talents in the country. Children giving up music due to difficult family circumstances. And I decided to donate piano talent. I found a program to discover children with musical talents. His mother with bipolar disorder, and she is died 5 years ago. The students who entered music and art high school and took never piano lessons. I started to give piano lessons for the students in Gangwon-do. Some of them are studying in the Seonhwa Music and High School and college, still preparing for university. She's preparing for college entrance exam in music education. She is pastor's daughter, sincere, smart, and rich in musical sensibility. 이것 좀 없어질 수 없어. Instead of lesson fee, she brings me homegrown wild grape, rice cake, corn, etc. When she got a scholarship, she invited me to a meal. How lovely she is. She studies at the Music and Art School now. Her father was a soldier and she gave up the piano due to financial difficulties, but she studied again through my talent donation. It's aria of Mozart, Zauberflöte, magic flute. I donated my language talent. I studied in Germany. For the students who studied vocal, classical vocal, is the music sheet.
안녕하세요. 명령의 예술 작업입니다. 브람스의 폰 미디어 단연적인 네, 다시 올릴게요. 스페셜입니다. 가사겠어요. 폰 미디어 이게 지금 브람스의 리트는 슈버트나 슈만처럼 가사에 굉장히 철학적 의미가 있는 것 같아요. 시에 따라 다르겠지만 그래서 여기서 일단 첫 번째 자체 선율을 내가 또 굉장히 다르거든요. 브람스는 화음이 어려워요. 그래서 피아노 파트를 아주 잘 알고 계셔야 노래 표현을 할 수 있습니다. 이게 근데 이게 발음이 하지만 너무 발음해 주시면 소리가 그냥 엔처럼 이렇게 발음이 되면
이거 다 나온 거야?
발음은 하나하나 했지만
안 되나 봐. 멈출게. Thank you. It was too long. It is a YouTube video. I donate my language. I write the text of German song on the paper, and its pronunciation, articulation, and so on. The student who studies vocal, they are not so, they took vocal lesson, but it's not it's very difficult to take a lesson for example, for German language and vocal technique. It's very expensive, so I have to tell. And because of that, I decided to upload the video about language and pronunciation, articulation, and interpretation. And the students study with my videos. It's very, very important for them. Yeah. How do I want to live? I wanted to do something that makes people happy with music. I wanted to let people know that art is not something special, enjoyed by the wealthy, and it can reach everyone's life. I want to provide educational opportunities to talented, music-loving children. I want to give a lecture with a performance that combines music and literature, especially human. I want to create a world where everyone can play music, especially instruments, including voice, one at a time. Not material things, but that there are more good things in the world. Because of that, I try to donate my music talent, and I'm so happy. I want everyone can donate and be happy. Because of that, I can ask you and ask for, shall we share our talents? Thank you. And one day I have received a message. My daughter fell out of bed at the age of 3. She can use only one hand. Could you recommend my daughter the piano music sheet? Her mother was looking for the piano music for her daughter. She found my sheet music by accident. I made videos for those who gave up due to being injured the fingers. One-hand piano. Mom's comment broke my heart. Thank you for listening to me. Yes. Thank you.
Thank you. Thank you for Dr. Myung's self-reflecting presentation. And any questions to Dr. Myung? Okay, Dr. Myung,
Yeah.
please remove the sharing screen. Okay. Yeah. Thank you. Thank you. Thank you for your good presentation. Thank you. Okay, the next presenters are Mr. Sriyansia, Mr. Shiho. Sorry. The next presenters are Mr. Suhardi and Mr. Utama. My pronunciation is correct? Yeah, okay. Suhardi. Rio. Okay. Yes. Yeah. Please give your presentation.
Well, thank you. Hello, everyone. Ladies and gentlemen, before I begin, let me introduce myself. My name is Rio Mardani Suhardi, and I work as a mathematics teacher in Junior High School Lamburet Batam. And currently, I teach in the 9th graders. And today, I want to share you my research about the effect of using STEAM plus 4D frame learning on developing students' computational thinking skills. But let me share my screen first. I'm sorry, can I share my screen, Mr. Choi?
Just a minute. Okay, yeah, you can share.
Okay, thank you.
Okay, we can see your screen now.
Okay, thank you. First of all, I'll show you a chart that show our country, my country, Indonesia, position in the PISA 2018. But let's focus on the yellow one. That was That one is the mathematical literacy. Our score is 379, but unfortunately, the OECD member country average score was 489. And I just found about the PISA 2018 that talk about computational thinking skills. The sentence is PISA 2022 framework is an appreciation of the intersection between mathematical and computational thinking, engendering a similar set of perspectives through processes and mental models that learners need to succeed in an increasingly technological world. Well, computational thinking skills in nowadays has become the buzzword for many teachers worldwide, and the PISA 2022 will be the first PISA to evaluate them. And it all began with my experience. I mean, when I was teaching, when I was given a question from the Bebras Indonesia Challenge to measure my student computational thinking skills. And from this slide, we can see that there are two samples of the answer of the student, the top one and the bottom one. The top one, actually, he can answer the question, but not relate to the questions, although with the opinion, but it's not related to the question. And then the bottom one, she can answer almost the right choice, but unfortunately, she have no idea how to explain it. And it's really fun. When I just asked to my student at the class, why many of you can answer that question? And my students be like, I'm sorry, sir, the question is really hard. It's really hard for us. And I don't know, I don't have any idea to answer that question. And then from that, and also from the result of the pre-test computational thinking skills, make me realize that my student computational thinking skills were quite low. So as a teacher, make me think that I should use another learning strategies. Then I think STEM learning will be an alternative to stimulate student computational thinking skills. And I know about the STEM is from the Simio Kitab in mathematics. And on the other hand, based on my experience while I was teaching in the grade 8 for the 2020-2021 academic years, I mean the last year, in general, students are very interested in STEM, but students still look less active during learning activities. I don't know why, firstly. And then from the Doctrine 2013 said that STEM will integrate artistic design, expression, reflective, and multisensory appeal that requires art to connect. Therefore, the use of art, which means A, will increase the attractiveness of students to be active during learning activities. Let's move to my research objective. The research is aims to find out the teachers' activities on developing the computational thinking skills of the 9th graders through STEAM plus 4 different learning at Junior High School Namborech Batam. And the research questions is, how is the implementation of the STEAM plus 4 different learning that can develop students' computational thinking skills? And the methodology, this research used classroom action research by Camis and McTaggart, which consists of 2 cycles, each of which is conducted through online meetings. This research used purposive sampling strategies. Actually, at my school, we have 239 students, but I just select one of the 6 parallel class. I choose the class 9-3 that include 40 students. And then the instrument used in this research, the first is lesson plan, including 3 main activities like water tower, straw bridge, and planting machine. And then the computational thinking skill test to measure my student improvement computational thinking skills, and also the interview sheets to find out how my student expression and how they're feeling about the lesson and after the lesson, and also how the lesson impact to their study habits. Well, there are some capture of my activities, I mean online activities, because of the pandemic. I should teach online by Google Meet. Actually, the 40 students is divided into 6 groups. And I name it the group 1 is STEAM 1, and the group 2 is the STEAM 2 until the group 6 is the STEAM 6. Well, we move to the task 1 is to build water tower. Well, in this lesson was carried out in the first and the sixth meetings. This in the first and the fourth meeting. This lesson inspired by water tower that designed by an ex-dictator Arturo Vittori to help Ethiopian people to produce clean water by condensation. I just also try to connect my local issue. In our region, sometimes face the long dry seasons, and I think it's really fit for us. And all engineering design processes in these activities went well, like as imagine, design, create, and improve. This learning trains students algorithm thinking, generalization, and abstraction by maybe when students make the prototype by using the 4D frame. The next one is to build Batam Bintan straw bridge in the task 2. Just try to connect with local issue also. Our government on progressing to build the bridge which connect to areas, our region Batam and our neighbor Bintan. This lesson was carried out in the second and the fifth meetings. In the beginning, I guide students to use Google Maps to find the actual distance between the two areas to train student algorithm thinking and evaluation skills. In this lesson, I try to emphasize mathematical concept and on similarity and congruence. And for science and principle of Newton's first law was introduced here. And the task 3 is to build planting machine. Well, in this lesson, students more look enthusiastic. Some students are more happy with something that can move, right? All engineering design processes went well. In this lesson, students use linear motions with constant accelerations to try their prototype to their design, the car, and using mathematical concept like volume of 3D objects and statistics. It is intended that students can try to do abstraction, decomposition, and generalizations. Well, let me show you the video of the implementation and also the interview with some of my students. And I hope you enjoyed it.
Saya lebih memahami tentang aspek teknologi
Well, the term is almost over, and then after doing the implementation, I collect the data, and based on the table, we can show the average score and the percentage of the students who reached the minimum score. And please take a look at this chart. It's about the average score of the computational thinking skill test, and the next one is the chart is about the percentage of students who reach the minimum score. Actually, in this research, I made a successful indicator criteria, that is the percentage of students who reach the minimum score at least 80%. In the past cycles is only 38%, and then I implemented STEM in the cycle 1 and got the 73% the improvement, and also it not close enough to the indicator of successful, so I have to continue the cycle into the cycle 2 and got the percentage in 88%. And now I end this presentation with the conclusion. There are two main conclusions that I got after applying STEAM plus 4D frame learning in the online classroom activities. The first is STEAM plus 4D frame learning strategy can develop student computational thinking skills in the 9th graders in junior high school, Namuraj, Batam. And the second, there is an improvement on students' computational thinking ability from cycle 1 to the cycle 2, and that is 15%. Well, that's all I want to share with you. Thank you.
Thank you. Thank you very much. Yeah. Any questions to Mr. Suhardi? Yeah, I was impressed with Mr. Suhardi's presentation. The laying marbles car, laying marbles car. It's a very creative thing. Thank you. Very impressive. Okay, we have not enough time, so the next presenter, Dr. Kim.
Would you mind setting me as the co-host?
Yes. Yeah. Host. Okay. Yes.
Thank you.
Yeah.
Okay. Sorry. Let me share it again.
Okay. Working well.
Yeah. Okay. So now. This is my sharing. It is learning mathematics in a digital environment in Hong Kong last year. Okay, let me introduce myself. I am a freelance researcher, educator. I work at different university as lecturer and some school support to support teachers. And now let me introduce my presentation. The episode that I took was from last year during the pandemic period. The first episode, some online lesson. The teacher used Zoom and Leaport at the same time during the Zoom lesson, and it found out that we can capture lots of student thoughts, because during the online lessons, sometimes we cannot get student response, and we don't know whether the student learn anything or not. But with this Leaport and Zoom at the same time, we can capture quite a lot of student thoughts. And the second part is about using some iPad, and we use the Mathicon Polypad to explore the division of fraction. Okay, so I think time is not that long, so I skip all those background, and I think and here the teachers, they develop the materials using the idea of learning by doing by John Dewey. They want the student to work on something, they build up their learning. It is from a constructive point of view. And and now let me explain a little bit about the first episode. These are some Zoom lesson, and you can see we can capture quite a lot of student work, and also student could learn in his or her own pace. And so during the lesson, if the student work a bit faster, they can move on to the next task. And also teacher can make use of student work and share it during the lesson time. And I have to stress this again, this was the online Zoom lesson. Okay, so the teacher conduct it this way. You can see the Zoom screen, and the teacher project the Leopard slide so that the student can use the draw it tool on Leopard. And you can see on teacher's panel, he could see lots of student work. Some students are working on the task. And now next, these are some student individual work during the lesson time. On that lesson, student they learn the concept of multiplication of fraction, but they do not have the formal symbolic way to write down the fraction. And even if we give them the number sentence, they don't know what they're about. So the teacher use some diagram, and they can just simply draw something on the Leopard screen. And this is the first example. The teacher go through it with the students, so you can see that quite a lot of students, they know how to handle it, because teacher had the demonstration, and the student follow how teacher explained them. And this is the second coursework, and you can see that there are so many different student work. They have different thoughts. Some draw the diagram, some just cross out the dots, and some just write down the words to explain it, and some write down the number sentence. And you can also see that the number sentence they wrote are not exactly the same. So you can see each of the student, they can have their own pace and do their own work. And you can see that teachers can make use of student works and apply some teaching and learning strategies. And let me, I don't explain too much to you. I just keep leaving this page for a few seconds, and then I move to the next page, and you can look at it. And later on, if you would like to have some look at some page, I can share it to you again. And we can see that there's some student mistake. They are not all correct. And this the lesson 1 classwork number 4. And they have different ways to get the answer. And generally, they mark it on the diagram, and then they write down the number sentence. Okay, and then the next one, this is the lesson 2, and again, our teacher explains some how to work on it. And if you look at the diagram for the first lesson, the diagram, the figure is on the left, but now the diagram is on the right. Okay, so in the first lesson, the diagram is the main way that helps student to get the answer. But now we put it to the right side so that the student consider the diagram as something that assists them to write down the number sentence. And the teacher would like to help them to understand the meaning of the question, and then hope that they could write down the number sentence on their own. But you can see that some students, they skip the number sentence. They just count the numbers. They have some marks, have some drawings. Okay, again, you can see the difficulties of the question becomes more difficult. And you can see the diversity. Some students could write the number sentence, but some wrote the wrong number sentence, but they can get the correct answer. So you can see that they did not know how to do the calculation, but they can count the answer correctly. Okay, here is another example. And I keep moving to this next slide. Okay, so this is lesson 3. Now, lesson 3, you can see that there was no little figure on this diagram, and on the left, and the teacher would like them to abstractly think about the numbers of 50 marbles. They cannot mark 50 marbles. They cannot mark so many marbles. And so how can they represent it with some little bars? It start helping them to use some bar model in understanding multiplication of fraction. And you can see some students don't know what to do and get angry and just draw some lines on the board. And again, you can see students, they have different answers. They have some common mistake. There are 5/8 green marbles. So they mix up the number and the fraction. So with these tools, the teacher could know the common mistake from student. Okay, so this is classwork number 4 of the lesson 3. Okay, so the question become much more difficult, and if the student, they can have the abstraction, later on they can skip the bar model and they can just simply write the number sentence. This is the way that how teacher direct student to learn multiplication of fraction during the pandemic period without face-to-face lesson. They could not go to see whether student do anything correct or not. But with these online tools, teacher could capture lots of student works, and teacher could find student mistake at an earlier stage. And the episode 2 is that there was 4 classes in the same year level. 2 classes used paper straight, and 2 classes use polypad in Mathicon to learn the concept of division of fraction. Okay, here are some classwork question. And this is the lesson episode. Some students, they cut the paper strip with some length, and then they fold it up so that they understand the division of fraction. And now this one, the student use iPad, they work in pairs with the Mathicon polypad fraction bar tools. Okay. And after the lesson, after a few weeks, they learn how to use Mathicon to do division of fraction, and teacher asked students to create their own video and upload it to Padlet. And here is an example.
Hello everyone, I am Daniel from class LE5. Today I am going to use Mathicon to demonstrate how to solve a problem. In this question, it has 2 kg of sugar are divided into bags of 1/4 kg. How many bags of sugar are there? First, I will use Mathicon to demonstrate. First, I use a bar of 1/1 to represent 1 kg of sugar. It has 2 kg, so I need 2 bars of 1/1. Then I use the bar of 1/4 to represent bags of 1/4 kg. So we will try to count how many 1/4 bars we need to make 2 1/1 bars. Finally, I found out 2 kg of sugar can divide into 8 bags of sugar. Therefore, the mathematical statement is 2 divided by 1 over 4 equals 8. There are 8 bags of sugar. Thank you for watching. Hello everyone.
Okay. So here I just like to pinpoint that. So during the pandemic period, it's hard for us as teacher to teach students lots of different teaching strategies. We cannot use them. But on the other hand, it provides us with other opportunities to help students to learn. And from this experience, you can see that students gain competency in using the digital tool because teacher would like to capture what student thought, what they learn, and it turns out that students they can use iPad, they can record the video on their own, they can record their own work, and they can answer the division problem on their own. And this is a perfect example of how students they can how they learn. And in this example, we can also see that video can be used as an assignment. We can give an assignment to student, prepare a video of how you do this division of fractions. So it is much more interesting than asking student to do hundreds of division problem. Okay, and here's some theory that they use about the learning by doing, but for this presentation, I just end here. And here are the school in Hong Kong, and I would like to thank those teachers who contribute to this result. That's the end of my presentation.
Thank you very much for your presentation. Any question? Yes, the Mathigons usage, I saw it very well, and I also interested in technology, and I work for GeoGebra also. So thank you for your presentation. I was inspired from your presentation. Thank you. Yes.
Thank you.
Yeah. The next presenters are Mr. Sri Yantia, Mr. Shiho, and Dr. No Hasana. Is there in this Zoom?
Yeah.
Yes, thank you.
Yes, sir.
Yeah,
I'm here.
yeah.
Okay, let me.
Okay, yes, yeah. You can share your screen.
Okay.
Please start.
Could you make me as the co-host, sir? Because I cannot share my screen. All right, already. Thank you. Could you see my screen now?
Yes.
Sorry. Okay, everyone. Okay, my name is Mr. Shakti Perdana. Okay, now I would like to present you about our research. The title is Bringing the Traditional Technologies of Fishing Trap, BUBU, into the STEM Classroom project. This is an ongoing research, and now in this occasion, I would like to tell you about the engineering design process that we conducted during this research. Okay, this is the introduction about our research. Our research, apart from, yeah, of course, the PISA score, the lowest PISA score of our country in Indonesia, that we are ranked 70 out of 77 in 2018, yeah, and then it indicated some 28% of students in Indonesia attend only level 2 and high or higher, and this stimulate us to thinking how we change the environment. And because of the STEM learning, the STEM approach, promising the new trend in science or mathematics educational research, so the use of the STEM learning has a great potential to improve the thinking skill. While in fact there are still few number STEM research that focus on mathematics field, and then the number is also limited. So that why we need to design one environment that use the STEM approach and the integration with the other approach. And in this case, we use the problem learning to induce the students to doing the engineering design challenge. And because the nature of systems is very compatible with the problem-based learning. So that why, in this case, we take the BUBU theme. We take the BUBU theme, the traditional fishing trap technology in Indonesia, and I think it is around the world, to be the STEM project for our students. And then I think this is the overview. Okay, actually this research focus on the mathematical literacy, but for now I will not discuss about the literacy, but I will introduce you and emphasize the explanation about in the engineering design process. Okay, the right side diagram can show us about the design, the various design of the BUBU, various model of the traditional fishing trap. This is quite different with the fishing weir. Yeah, this is the fishing trap, and Indonesia itself we call it as BUBU. Okay, now in this case, as I said before, we design the instruction using the problem-based learning that proposed by Aaron. Okay, and we start from the orienting student to the problem, okay, and organizing student for study, assisting independent, developing and presenting their fact, and evaluating the problem, okay. And it is aligned with the engineering design process that involve ask, imagine, plan, create, improve, and then all of the design process can be integrated in all instructional stages. Okay, I introduce you with the STEM component of this theme, BUBU theme. Okay, the BUBU, as you can see in the diagram, so many model, and then I will try to break down into each part of the STEM science. In this activity, actually students have to demonstrate a working understanding of density, buoyant forces. Okay, when they determine whether or not the trap they constructed need to be mounted with ballast, and then where the appropriate location on the river where the trap should be installed. While for the technology itself, we use a 4D frame, we use a magic straw, actually, especially a 4D frame, yeah, in this case, instead of using bamboo, the real one using bamboo. Okay, we can also integrate the GeoGebra, but in this case, in our research, we only integrate with 4D frame. While for the engineering design, actually, this is the important aspect, yeah. The aspect is demonstrated with each group given the same material. Of course, this is 4D frame kit, if possible. Why I say this is if possible, because during the pandemic, as the presenter before previously said, that during the pandemic, the student cannot access directly the 4D frame kit. So that why in our research we propose them to use the material around them that can be used to construct the design, and all the designing and construct different model of fish trap. They should create the best design of the fishing trap. While for the art, of course, the aspect of the art, students need to consider how their design works, so that customers are willing to pay more for product to design, look, feel, and better than the other groups. While now we focus to the mathematic aspect only, yeah. Okay, while as I say, this is ongoing research, so the remaining aspect, especially for the science, we left behind. Okay, for the mathematics itself, each group need to perform and validate calculation and how big the volume of the trap they can construct with the specification of given material. This is the student need to study about the shape and area, the volume bounded by the trap. This is the problem. Okay, this is the engineering design process that I emphasize to the student: ask, imagine, plan, create, and improve. Okay, this is the actually what I can summarize the lesson. Identify the challenge, okay, and develop the background knowledge, plan, implement, and test and evaluate. Actually, I will talk to you about the product and the worksheet. In every step, especially for the developing the background knowledge and plan or planned, we accompany the student with the worksheet, and so that they can directly learning about the concept of the cylinder, of cube, prism, and space and area, the volume, how to calculate the volume during their process, engineering design process. Okay, in this case, this is the result of the student. This is the result of the student. You can see this one. Okay, even though this looks simple, so simple, but it gives the greater emphasis and greater support, yeah, for the student to learn the design. Okay. Okay, this is actually the main worksheet, yeah, because when the student, okay, the student actually, we divide the student become 6 group, okay, 6 group, and each group need to build and to design the model of the fishing trap, Bubu, for example. This one, they need to modeling by using a prism and cuboid, and the combination between the cylinder and the cone, and then model C, they need to design the cylinder only, and the next model they need to design a prism. And the problem is, the big problem that we give to the student is which design that can result the effective and the bigger volume, so that we can trap the a large amount of fish. So during the class discussion, the students were really excited to discuss about their design actually, okay? They construct the design and then directly measure the component, the length, the diameter, and the height of the design, and then directly compare with the other students. This part is really excited for the students. Okay, let me show you once again. This is the sample of the design that constructed by the students. Yeah. Nah. Okay, the most interesting part is when the engineering design process occurs in the classroom is the first one is the student think that Bubu is like a rocket. Yeah, Bubu like a rocket. Okay, they construct the first one like a rocket, and then after that something happened. Yeah, ask, imagine, and then evaluate again. The student asks about the openings, the door of the mouth of the Bubu. Actually, sir, what is the function of the mouth and the opening actually? And the first, they construct the cone with the hex support of the 4D frame connected all of the part, so that why it closes. Okay, it closes as the openings, so that why when the student asks me and the teacher, we suggest them the criteria and the function. Oh, the function of the mouth is to trap the fish, so the fish can open from the outside but cannot go inside. It closes from the inside. Now, and then this is the scanner video. The next one, they construct the firm structure of the opening. Is it correct, sir? They a group was asking the teacher, is it correct when they construct this firm structure of the mouth of the opening? So of course it's incorrect, but they need to rearrange and redesign the mouth, the opening. And the next, and this is the last one when the group result the correct design. Yeah, so they have a mouth, the opening like a cone, this one. After that, the most interesting part is the student elaborate their understanding. Yeah, elaborate their understanding by what? By designing a lot of openings from the top and the bottom like this. Yes, so they ask about the science, even though it's mathematics lesson class, mathematics class, and then they they just asking me about the science. What is the science behind it, sir? Do our old people know about the science before they construct it? Okay, also it introduces them, yeah, okay. Next, okay, the design of but the next one, after they constructing, we give them simple question as the post test. This is Makoko floating school, yeah. And this context really interesting for them because, yeah, the description that we provide attract their attention so much, even though in the beginning when they had a pretest, they cannot solve this question because I think maybe it is quite complicated for them. But after reusing a 4D frame and design the model, show them what the component and what the length that should measure, they can solve it. And this is the sample of their, they can visualize, even though they can draw in their own, and then directly can make the 3D model and then label the length of the 6 length that they should measure, how so that they got the volume of the building. Okay, this is the this is attract our attention to dig a lot about this, and I think we will discuss and present the result for the next paper. And I come to my end. Well, my closing remark is the dynamic model of fishing trap can be designed by utilizing the flexible nature of the tool to form spatial formation. In this case, we use a 4D frame, we use a magic straw, and it was also used to teach solid geometry, as I said before, covers curved surface and section. And through this study, we may provide useful information about classroom activities that integrate STEM in learning mathematics. Thank you for the chance. If you have any question, let me try to answer the question. Thank you, sir.
Thank you.
Give back to the MC.
Yes, thank you very much. I was impressed because this trial is very important that the cultural assets of Indonesia was implemented by mathematics and science. So very good cases for STEM education. Thank you.
Thank you, Mr.
Yes, thank you very much. Yeah, the next presenters are Mr. Nukuhara and Ms. Sarma.
Yes.
Thank you. Yeah, thank you. Yeah.
Please allow me to share my screen.
Yes, working
can
well.
you see? Okay, thank you. Good evening, Excellency, moderator of the session, respectable all the ICAS committee and honorable all of center and audiences, ladies and gentlemen. It's great to see you all. Here I am Tantan Sutani Nugraha, a mathematics teacher from SMPN 2 Ciamis, one of junior high school in West Java, Indonesia, as researcher together with Miss Umi Salma from Simeo Regional Center for Kitab in Mathematics, Yogyakarta, will present a research entitled Fostering Student Higher Order Thinking Skill Through STEAM Integrated Project-Based Learning by using 4D frame. Before explaining the process and result of the research, allow me to show a short video about brief overview of student activities in our research. Can you hear an audio?
No, we can't hear.
I'm so sorry.
Okay.
Assalamualaikum warahmatullahi wabarakatuh. Sampurasun. Annyeonghaseyo. In STEAM, or Science, Technology, Engineering, Art, and Mathematics project, we made a miniature house that used wind power as an energy source. For the windmill, we use for the frame, which is combined with other materials. We learn some concepts in mathematics such as area of a quadrilateral, angle measurement, slope, and the Pythagorean theorem. In the field of science, we learn and apply electrical concepts and inclined planes. We feel this project has a lot of positive impact and a new experience for all of us. This project trains us to think critically. For example, when determining the large area of a house with predetermined materials, and also trains good collaboration in a team by shared text. Warm greetings from us at Tatargaluh, Ciamis, West Java, Indonesia. Sigan Nejoyoso Kamsamida, Moduge Kamsamida. Wassalamualaikum warahmatullahi wabarakatuh.
As background of this my study, we all know that 21st century learning skill in the form of forces, that is critical thinking, creativity, communication, and collaboration must be learned by a student. And in fact, in our school, by observation and preliminary research, the ability of critical and creative thinking of students is still low. And here, teachers have the opportunity and responsibility to train students with these things, all by designing appropriate learning. In its development, by making it learning approach, STEM or STEAM can explore creativity and learn connection. It provides an opportunity to increase student experience in hand-on practice and allow them to incorporate and apply related knowledge. And also, the project-based learning has a syntax that facilitates various stages in the STEAM approach, including in engineering design process. And in our study, component of STEAM maybe can consider at format. The student learn about lines, angle, measurement, shape, and space, especially about area and perimeter. Also about science and technological, about electricity, engineering, how to design the shape, arrangement, and working on this device. And art is something to make result more aesthetic. This is the objective of our study, that is to describe with the STEAM integrated project-based learning, foster student critical thinking and creative thinking skill, and also describe how the implementation of problem-solving step in learning process STEAM integrated project-based learning. This is some literature review about STEAM and project-based learning. High quality STEAM education is high quality project-based learning. Then STEAM and project-based learning have many similarities, then also about integrating of STEAM or STEM with project-based learning is a model of teaching learning. And about higher order thinking skill, many experts give some definition about higher order thinking skill. Some of them give definition HOTS equal by critical thinking. Then HOT also interpreted as problem solving. Also, HOTS often intersect with some critical thinking skill, problem solving abilities, reasoning abilities, and so on. And in this study, higher order thinking skill are critical thinking, creative thinking, and problem solving. So this is indicators for critical thinking and creative thinking skill in my study. Then also about problem solving in this research, yeah, according to Polya, understand the problem, devise plan, solve, and looking back, of course. And this is methodology of our research using pre-experimental with one group pre-test post-test design. That is a design include pre-test measure followed by a treatment and a post-test for only single group. Also considering the pandemic condition that can be totally face-to-face learning. Teaching learning had by blended learning. Yeah, the initial meeting was conducted online to provide an overview of STEAM and the project to be worked on. Then face-to-face for limited numbers of students. For the second until third and fourth meeting, yeah, totally there are 4 meetings for this study, and instrument for quantitative instrument pre-test and post-test by using essay equation to measure critical and creative thinking, and then analyze using pair sample t-test by SPSS and qualitative by observation sheet. This is how to implementing of learning, yeah, tool and materials. In addition to the 4D frame kit as the main material in the implementation of this learning, also use infrared board, dynamo cable, and LED light, in addition to tools such as scissors and cutters. And maybe we only use a few types of the frame contents, namely 6 cm and 10 cm tube, 6 ways, and H-way connector, while the other type are used as accessories related to the artistic aspect of the design. So we have 2 times 2 times 2 times 3 or 24 combination. Yeah, student in group have to try for 2 kind of length, 2 kind of number of blade, 2 kind single or double, and for 3 kind angle. This is some example of windmill design. This is windmill design with 6 cm single, 6 blades, for 0 and 30 degrees angle. This is windmill with 10 cm double 6 blade for 30 degree angle. This is also with 10 cm double X blade. This is result. Yeah, the left one is house miniature design, and the right one is how to student test design with voltage and current measurement. This is the table of result measurement about voltage and current for several combination of length, angle, and the number of blades. Yeah, for this combination, only 3 combination that make the LED light up. Yeah, that is for 10 cm length with 30 degree angle for single mill, 6 cm and 10 cm length also with 30 degrees angle for double mill. So from this data, it can also be concluded that among the specific angles, 30 degrees give the best result. And this is for indicate that the LED is light on. This is also accordance, yeah, with one reference with state that the minimum voltage to be able to turn on the LED lamp is about 1.7 volts. And the second group do the second case, that is for SIG blades for single and double, but similar experiment using SIG blades, so even worse results. Yeah, none of the combination can turn on the LED. Yeah, none of them. So we can conclude that the base composition that produce the largest current and voltage is SIG blades, which are ranked double at an angle of 30 degrees. This design is then applied to the house. This is good line for the test, that is pre-test and post-test. The content are slope, Pythagorean theorem, rectangle, and also angle, and context-nya height and slope of roof, size of home wall, and design of windmill blade. This is maximum score, and here one of sample problem. This is example of problem related to determining the maximum area. If we have two length plus one width, students are asked to determine the maximum area. Yeah, that is length time width of the rectangle. Of course, science students have learned calculus. Yeah, so they must first calculate it by trial and error. Then this is the result of pretest and post-test. Generally, for pretest, we have 43.44%, and for the post-test, we have 61.56%. But by using SPSS, that is by sample test by SPSS, we test one by one for every indicator, then critical, then creative, and also for critical and creative thinking. And not all of them significantly different. Yeah, some of them may be different, but statistically there is no significant. We can see for the first indicator of critical thinking, this is not significant, yeah, because the value of SIG is more than 0.05. Also for the fourth indicator for critical thinking skill, and also for the first indicator of creative thinking skill. But generally, for critical thinking skill, for creative thinking skill, and for critical and creative thinking skill, before by pre-test and after by post-test, saw the significant increasing. Maybe some of them is not significant. This is understandable. The increase didn't occur significantly in the part of the question that were considered easy. Yeah, so that even before learning, the student were quite able to answer them. Or on the other hand, it also occur in questions that are considered very difficult. Yeah, for difficult problems, so that the learning doesn't provide sufficient additional ability to solve the problem. But generally, we have a conclusion that STEAM integrated project-based learning could improve student higher order thinking skill, especially critical thinking and creative thinking. Thank you. That's all of our presentation.
Thank you. Any questions? Yeah, thank you. Students doing their own research is very important in STEM education. Yeah, I also agree with your thought. Thank you. Yes.
Thank you.
Yes. Yeah. The next presenter and the last presenter is Dr. Roy Lopes. And thank you for joining this live workshop because you're a very famous man. I've heard lots of time, and thank you very much for waiting long time. And please give your presentation.
Okay, well, thank you for inviting me for this session. And I don't have to share my screen because I present live objects. And the thing I want to talk about is the making of models of platonic solids. If you talk about platonic solids like this on the dodecahedron, and you want to make a wooden model, it's quite complicated because you have to know all the angles between the faces of the dodecahedron. And that's not easy to calculate. And for most of the platonic solids, this is the case. So only the cube is a very easy model to make because we all know that the angles are 90 degrees between the faces. And nowadays, there are a lot of schools who have access to a laser cutter. And with a laser cutter, it's very easy to make models in this way. To construct a 90 degrees angle, you just make those parts and well, you can take them apart very easily. And in total, you have the cube. So now my question was, if it's so easy to use 90 degrees angles to make constructions, is the cube the only thing you can make then? Well, of course, you can go on with cubical constructions like this, but that's not what I was looking for. Can you make other objects going outside the cubic grid? And well, I started in this way. Well, when you take just one part of one angle of this construction, you have this one. So you can recognize the triangle because you see 3 lines of connections. And well, in total, you need 6 parts to make this model. Well, if this is the triangle, the first step was to go on with the square. So also this one has construction angles of only 90 degrees. So this angle here over here is 90 degrees. So you have to calculate the angle first, but then you can make this model and can construct it very easily. So from the triangle to the square, you can go on to the pentagon. So you're now in the field of the polygons. And when you have the pentagon, we know there are 2 kinds of pentagons. You can also make the pentagonal star. And also this model can be made with only 90 degrees construction angles. And you see that from the pentagonal star, you end up with the knot, the 5-2 knot. So from the platonic solids, you switch to the field of knots. And well, just to show a few more examples, this is the 8-3 knot, which becomes a very nice model. So very easy to make. The constructions are all 90 degrees. You can make all the parts with laser cutting. And well, one more complicated example, which gives very nice models. And you learn something about knots and applying the 90 degrees angle. So this was the first group of objects that I found which were interesting. Another idea was to start with the cube again, like this one, but to cut off a part of the cube. So now we've got 3 open edges, which we could use to add more objects. So those edges are now used to add more triangles. And if you calculate the top of the triangles in such a way that this triangle is also a 90 degrees construction, well, then you have this one. So in fact, what you do is you build a second ring on top of the cutted cube. But now all the angles are still 90 degrees. This is just a first step to enlarge a construction based on the cube. And well, when you take more steps, I will show the final model, then you end up with something like this. So just starting from the cube and applying only 90 degrees constructions, there are a lot of possibilities to make interesting shapes. And so, well, it's nice to see it from all sides. And so this is another way to go on. Well, when you start cutting off pieces of the cube, you can also do it in this way. So you recognize the part of the cube, but I now use the diagonals of 4 of the faces. And again, I can do it in such a way that when I add a triangle in this way, I end up with, well, where is it? Oh yeah, over here. I end up with this module. So again, I started with the cube in this. I cut off along the diagonals, and I filled it with triangles, only using 90 degrees angles. And now I ended up with a module with just square, a square outline, so 4 open edges. But if you add more modules, you can make beautiful constructions like this. And in this way, I found a few other modules, like this one. This is a triangle. You can recognize a part of the cube still. And when you use those modules to make a larger construction, you get this nice. And these are all easy to make by students because all the angles are 90 degrees, and you can just make a lot of parts and put them together and make beautiful constructions. A last example in this series is based on this module. So again, a cube as a basic part, but with the extra ring, I end up with the triangle. And well, I think this structure is very beautiful. As you can see here. So these are these can be nice projects for students to make those models and also to think about other possibilities. Well, I started with the remark that it's quite difficult to make a model of the dodecahedron, but also with the limitation of applying only 90 degrees angles, it's possible to make a nice model of the dodecahedron. And I want to close my talk with presenting this model. So this is the dodecahedron, but if you look close at the construction, you see only 90 degrees angles. So this completes my small talk about the constructions with only 90 degrees angles. Thank you.
Thank you very much. Any questions to Dr. Roelofs? Yes, we can have time to ask him. Oh, thank you, very impressive and wonderful. Every cube or every Platonic figures can be created by 90 degrees. Very impressive things, and I want to study why the region.
Okay, well, I can help you. We can get in contact about this if you want.
Yes, I send you email to you.
Okay.
Thank you very much for your presentation. Yeah, thank you.
Yeah, well,
Yeah.
thank you.
Yeah, you know, we have all the presentation, and yes, this is the end of the end of the program of this day. And the next day we have GeoGebra workshop, the present and future of education using dynamic math software. Yeah, and the after the session 7 is the first session with metaverse, and you already have the introduction email, so you can experience the metaverse. Okay, thank you very much, and I appreciated your precious presentation. Thank you very much, and see you next day. See you next day. Thank you.